civilization of the ruler, the weight, the protractor, and sand glass. Since ancient times, humans have ascertained the size, amount, or degree of something by using an instrument or device such as ruler, spring balance, protractor, or sand glass. Measurement units were different and used to be sacral. For example, the number 60 in the numeral system was sacred for Sumerians, gave rise to 360 days in the year, and survives in the form of degrees, 360 degrees in a circle, or 60 degrees in an angle of an equilateral triangle, minutes and seconds in trigonometry, and the measurement of time, respectively. Measurement units also used to be imperial. Who knows why a troy ounce or pound is equal to an exact quantity? Perhaps it was due to the weight of the plaster cast of the fist of the Roman emperor. Maybe the length of the English foot is defined by the length of the foot of the English king. All we can say is that measurement units were derived from tradition, in other words, through agreement between many peoples, which survives in the form of 12-base or 60-base numeral system and has been such a popular multiple historically. For example, 12 months, 12 inches, 12 ounces, 24 hours, and so on. Ancient measurement units, length, mass, and angle of rotation, survived for use in later experiments by the natural philosophers. Such experiments began with the conception of force. Experiments led to the discovery of Hooke's force law, Newton's force law, Cavendish, Coulomb's force law, Ampere's force law, and so on. These force laws were discovered and confirmed by experiments where just two interacting objects are considered. For example, Hooke's spring and small weight, Newton's two masses, Coulomb's 2-point ball bearings, and Ampere's two conductors. The term force came into fashion. The force of spirit, the force of imagination, the force of thought, vital force, and so on. The natural philosopher Robert Hooke used the concept force in scientific practice when he improved spring marine chronometers which kept time on ships. In his experiments, Robert Hooke hung a pan with known weights onto the hook to the end of a suspended spring. Then he noted the displacements of the pointer regarding the ruler and measured extension of the spring. He then divided the mass of the weight by the value of displacement. Hooke divided the mass of the weight by the value of displacement and called the derived amount the spring rate, or chi, or later the coefficient of elasticity of the spring. The force with which the spring pushes back and prevents the falling of the pan with the weight onto the ground. In Hooke's time, the law of universal gravitation had not yet been discovered by Newton, was called by Hooke the elastic force of the spring. Remember that the basis of Hooke's measurements was the weight. The mass of the weight was defined by the extension of the spring and its 1/12th part. 1/12th of an imperial pound was defined by an agreement between people from ancient times. The second basis of Hooke's measurements was the ruler. The length of the ruler was defined by the extension of the spring and its 1/12th part. 1/12th of an imperial foot was also defined by an agreement between people. Henry Cavendish measured the force of gravity between masses in a laboratory. Torsion balance was constructed on Cavendish's order. The torsion balance consists of a horizontal rod suspended from the middle by a vertical elastic wire. Two small lead balls are positioned at the ends of a horizontal wooden rod. The calibration of the elastic wire is made with the help of fibers which are tied to the small balls, perpendicular to the rod. To calibrate the torsion balance, similar weights are suspended to the end of fibers. Weights turn the rod at a fixed angle around the vertical elastic wire. The angle of the calibrating rotation of the horizontal rod is measured with the help of a protractor. A protractor is graduated in degrees and minutes, according to the ancient 60 numeral system. Then, 2 large balls, equal in mass, are positioned on alternate sides of the horizontal wooden arm or rod of the balance, close to the small balls. Their mutual attraction to the small balls causes the arm to rotate, twisting the vertical elastic wire supporting the arm, which is calibrated with the weights and protractor. Remember that the basis of Lord Cavendish's measurements was weight, the same as for hooks. The second basis of Lord Cavendish's measurements was the protractor. The protractor is marked in degrees, as it was established through tradition and agreement between many people who cared about the knowledge of Sumerians, still unknown for people in the 17th and 18th centuries. Lord Cavendish discovered the force law regarding the interaction between 2 charges with the help of torsion balance. He classified his discovery very securely, as he was worried about it being used by the military, so only Maxwell could publish them. However, Coulomb rediscovered this in any case. Both the results of Lord Cavendish's experiment with a torsion balance and Coulomb's experiment can be brought about using a ruler and a protractor. Everyone can carry out an experiment with charges using the ruler, the protractor, and weights, which are symbols of conception of force. Following the fashion of force, the property of non-conductors of electricity that enabled them to attract or repel was called the force of electrical charge. We have some questions. What is the force of charge? How do forces of charges appear between non-conductors of electricity? What body in a non-conductor is applied by force of charge to? What does a force of charge transfer? Why is force of charge scalar quantity and is not vector quantity? Why is a force of charge defined not as a Coulomb unit, but as a Newton unit? Let's create a virtual experiment with the help of weight, protractor, and ruler. First, create 2 non-conductor balls. Weigh the balls with the help of virtual weight. Suspend the balls to the ceiling with the help of non-conducting and non-electrifying threads. Measure the length of the threads. Electrify the balls. Remove the connections to the left ball and substitute the inclined thread with the vector T of the tension of the thread. Draw the ball as a free object in the equilibrium state under the action of vector T, gravitational force mg, and the visible force of electric interaction. Vector equation of equilibrium. Measure with a protractor angle alpha between the vertical line and every thread and verify that alpha 1 equals alpha 2 equals alpha. Equality proves that close balls receive an equal portion of electricity. Draw axes of the coordinates OX, OY. Project the vector equation of equilibrium. Accept unknown tension T, divide the first projection of equation by the second. You will arrive at the experimental amount of the modulus of Cavendish-Coulomb's force. Substitute derived equation. Mark the length of thread as L, and write the formula for modulus of force of charge. Here we are able to verify that the dimension of the force of charge contains newtons, derived unit of force. Perhaps besides the fashion for force, the conception of the force of charge appeared in order to call electrical the property of non-conductors to attract or repel 2 bodies. Later, the word force in the force of charge, in other words, the old school name of the force characteristic of electricity in non-conductors, vanished. The force of electric current, or modern electric strength, follows on from the fashion of the conception of force. The force electric current is the property of electric conductors to attract or repel while being connected to the source of electromotive force. We have some questions. What is the force of electric current? How do forces of electric current appear between conductors of electricity? What body in a conductor is applied by the force of electric current to? What does an electric current transfer? Why is the force of electric current scalar quantity and is not vector quantity? Why is the force of electric current defined as an ampere unit and not as a Newton unit? Do a virtual experiment. Create two absolutely equal wires, conductors. Virtually stick one conductor to the ceiling and suspend the second conductor by the spring from the ceiling in parallel to the first. Make sure that the gravity axis of both conductors is on the one vertical line. Connect one conductor to the source of the electromotive force. Connect the other conductor to another equal source of electromotive force. Verify that the spring is shortened. Weigh the conductors with the help of weights and measure their equal lengths. Remove the spring and substitute it with the action of Hooke's force, Fh. Draw a lower wire as a free body in a state of equilibrium under the action of vectors Fh, gravitational force mg, and visible amperes force Fa. Make the vector equation of equilibrium. Ampere ascertained dependence. Measure with a ruler the deformation delta x of the shortened spring. The formula for modulus of Hooke's force with spring deformation, here chi, coefficient of the spring rate. Project onto axis OX vector equation of equilibrium. Hence, it appears that the value of the modulus of Ampere's force obtained in the virtual experiment is: it is proposed that whilst equal conductors are connected to equal sources of electromotive forces, there will be equal forces of electric current. Then we get the formula. Verify that the dimension of the force of electric current contains newtons, derived unit of force. Perhaps besides the fashion for the force, the conception of the force of electric current appeared in order to call electrical the property of conductors to attract or repel two bodies while being connected to the source of electromotive force. Remember, we only need the weight and the ruler to carry out such electrical experiments. Note that the interaction of wires containing electricity is the only real factor in the theory of electricity and substance. Measurements of lengths of wires and distances between wires, shortening of springs and weights of wire are also real observed parameters of such interaction and can be measured with the help of weights and the ruler. At the end of this episode, let us say that the population of our planet is delighted with modern technology, but in our technocratic civilization, it has already gone clean from our minds the amazing simplicity of the measurement system. This is a civilization of rationality, but also irrationality, a civilization of extension, but also vortex, a civilization of reality, but also fantasy. All kinds of equipment in our energy, electric, nuclear, thermonuclear, high-tech civilization, including electrical measuring instruments, are based only on the ruler, the protractor, the weight, the normal cell or battery, and quantum standards of time, which substitutes the spring chronometer and earlier the sand glass. Let us suppose that we are virtually attending a presentation where a natural philosopher calibrates one of the first measuring instruments using the force of electric current. The first ampere meter, or ammeter to be presented, is a cametone-shaped or tuning fork magnet. Beforehand, the magnetic force of the magnet was calibrated by the attraction of a piece of magnetic material. The weight of the magnetic material is equal to the mass of the weight. The calibration is produced with the help of a spring. As we remember, the spring is calibrated with the help of the weight and the ruler. A flat coil of wire is placed in the air gap between the magnet poles. A constant electric current of unknown force from the source of electromotive force flows through the flat coil. The source of electromotive force is called the standard cell or voltaic pile or battery. The task of measurement is to define the unknown force of the electric current. The coil of wire is able to rotate, carrying a pointer with it and showing the angle of rotation on the protractor or scale of instrument. The rotation of the coil is limited by the opposing torque, which is produced by the spring tied with the pointer. The spring returns the pointer to 0 degrees on the protractor, 0 of scale. Then the constructor attaches the poles of etalon to the ends of the coil wire, carrying the pointer, and writes down the angle of rotation. This historical and even epochal event was forgotten due to the time. Mass etalon, weight, length etalon, ruler, and etalon of electromotive force, battery, are produced and calibrated using similar procedures and stored in specific places. Such analysis shows that mathematics, ruler and protractor, mechanics, weight, and electricity, battery, have no inner rational connection. There are no difficulties in showing that all kinds of electric measuring instruments calibrated in different units have their basis in the form of the ruler, protractor, weight, and normal cell or battery. Just remember the Babylonians who developed a circle character for 0, and note there is no etalon of protractor because full rotation or one complete circle is an irrational amount of 2 pi radians. A radian is an irrational amount when translated into degrees. Such irrationality is less evident when a real ruling machine cuts real angles on real protractors.